Is it going to be brutal if we turn the first row of lights off? Okay.
Yep. So I gave a presentation here about EGP and net neutrality, and afterwards turn into a lively debate on maritime net neutrality. And by the way, I will run ISPs as my assignment. So, you just covered your laptop. Good. Yes. So for the presentation, I actually for that presentation, I actually used Google Hangout, and for it to watch it after, watch it live. But one of the cool features of Google Live Hangout is as soon as the presentation was done, it was available to without any additional things. No students, I think they were. Pop-up email on this presentation for anyone that wasn't present. So hopefully we can get anything for yourself too.
So that's the idea behind what Southeast Linux Fest is going to be doing. They're, Jeremy, we're live now. Okay. Do you want to talk about it, or can we talk about it afterwards?
We'll talk about it afterwards, but I'm listening.
We'll talk about it afterwards then. So without further ado, I'll give it away to Tim.
All right. Am I coming through? All right, cool. So most of you guys know me. My name's Tim Fowler. I've been working on a research project for the last couple of months that I was really excited to be able to actually reload the project code and the project last weekend in Huntsville, Alabama. Essentially what I've been working on is building a wireless sensor network for data analysis and things. So this is most of these slides are directly from last week, last weekend. But the title of it's sensory perception. This is a bunch of who am I that nobody cares about. People don't care about this other stuff. One thing, the triathlete, if you guys know me from last year or so, I'm down about 113 pounds. Still got a long ways to go. Did a triathlon at the end of last year, and I've got 7 this season. Start first one in 7 weeks, which terrifies me because I'm 4 weeks behind. But what can you do? Life. So a little bit about this project and where it all started. It really started last year when actually started about 3 years ago. There was a couple of projects that were released dealing with wireless sensor networks and different aspects of wireless data collection and things like that. The first one was a project called Creepy Doll. It was released by a gentleman named Brendan O'Connor with Malice Afterthought. He released it at Black Hat, I think, in 2012, maybe 2013. I can't remember. It was completely creepy, completely awesome. And if you guys know me, I've got a background in wireless, and so when I first saw this project, it really just kind of intrigued me on how he was doing. He had an objective of creating a disposable sensor network. In disposable terms of the sensors are under $50, and if you lose them, it's not the end of the world. For me, losing $50 is the end of the world. But anyway, so what he's got, this picture here, you can see this is a 10-node system. It's about $500 of cost. But he was able to do some really interesting research with it. So this is one of the first projects that kind of got me started in this notion of sensor networks. And then the big project that kind of pushed me over the edge. Called Project Post. And then last 2013 summer, they released the updated version of that called Snoopy NG. It's a sensor network project. But what really set it apart for me was the fact that at Black Hat Asia this past year, they actually attached the sensors to drones and flew them around. And so now we had aerial sensors, which was just a crazy combination. Leave it to a bunch of hackers to take drones and wireless and throw them together and see what we can do. And I'm going to have to mute this volume because I hear myself. So these are projects that I've looked into. I've played around with them. I've set both of them up. in some form or fashion. Really, really cool, but I was never completely satisfied with the way they worked and the way they handled specific elements of the sensor network. But what's funny about it is that last year I was challenged to submit a presentation to Hacker Halted, which is an EC Council Foundation event. It's really, really fun. But they had a theme of the zombie apocalypse, and all of the talks had to be about the zombie apocalypse, how we could utilize technology to either hurt us or help us survive and stuff. And I was really, really scared because I'm a wireless guy, and I got to talk about zombies. And so after about 4 minutes of panic, it really just kind of came to me, and I wrote out the outline. And so I gave the presentation, When Zombies Take to the Airwaves. And the premise of this was that you have an existing wireless infrastructure within a municipality that in the moment of zombie apocalypse and outbreak.
You can change what your screen share is. I see your open office, but not your active slide.
That's maybe easier said than done. Let's see. Yeah, screen share. Let's try this one. Is that back? All right. So, if anybody's watching, you haven't missed a lot in terms of slides because they're really boring. But not death by PowerPoint boring. So anyway. The premise was that in this environment, during a zombie apocalypse, that because we have a wireless infrastructure in place, and because of the nature of the data that you can get from these enterprise-class wireless infrastructures, that we would actually be able to use the data that we've collected over history since the network was deployed to actually run calculations and predictions of where people are moving and how they're reacting to the zombie apocalypse. And so what we'd be able to do is look at the movement of devices within the network grid, and we'd be able to make assessments and things and eventually save the city. We failed, but it was a nice objective of trying to save the city using wireless technology. And it was really cool because anybody familiar with the Register in UK, the news organization, they actually ran an article in October about my presentation on this topic. It turns out that it was clickbait because it was 2 days before the relaunch of The Walking Dead, but I don't care because it's still freaking cool. My phone was blowing up at like 7:30 in the morning. Everybody's like, dude, get online, get online. I'm like, I'm still asleep, and everybody's like, you're famous. But the whole premise of it, and you can't really super see it very well. Let me see if I can go back. Yeah, is that if you look, we've got a little person in black that doesn't show up really good, but they've got a smartphone. And at the point in time of infestation, the results are we now have zombies with smartphones, which is just a really interesting concept that's kind of far-fetched. But understanding the way that our devices are working and stuff, there's going to be some inherent differences between a human being with a smartphone and a zombie with a smartphone. And using those characteristics, we were able to kind of map out and look and where the infestation was kind of like ground zero, and watches as it moves out and watches how people react. It also gave us the ability to be able to effectively communicate by injecting instruction sets into the airwaves so that they pop up on wireless devices and things like that to try to guide people to safety. It was a really far-fetched idea, but I had a lot of fun with it. People seemed to really enjoy the topic. The question that I got time and time again is like, have you done this? And the answer to that is, well, kind of, sort of. Have you Creepy Dog since both Snoopy and Snoopy and a few other side projects, but none of them really kind of captured the type of data and the specific types of data that I was looking for. And so looking at primary objectives from 2015 in terms of my research and my presentations, I was like, why not? Let's just actually do this. Let's turn this concept into a real life project that people can actually play around with stuff. So last Saturday I released really, it's my first open source project as a solo release, which is nerve-wracking because it's my code, which is really badly written, although I had some ways with it. And so I released the Harbinger Sensor Network project, and I chose Harbinger for a reason, as we'll get into in a little bit later, is because by the definition, a harbinger is a person or thing that announces or signals the approach of the event. That's really what this network is doing. It's real-time data, being able to make predictions of when events and things are going to occur within the network. So, a couple of core objectives for this project is to create a distributed sensor network for data collection, traffic flow, and migratory pathway analysis. That's a mouthful. I wanted to see how things move in 3D space through a predefined infrastructure, such as a runway or stuff like that. Because you would think that, okay, it's very predictable because it's roads, but in fact, there's really finite pathways and variations of how people travel even through a closed system such as highways. And I also want to create an analytics engine for data processing and visualization rendering. This is the biggest step of the project because all of the data that we collect is completely useless unless you can do something with it. And also you've got to make it pretty for like C-level executives and stuff, so make it shiny. The biggest question that I got when I started telling people what I was doing is why actually create a project like this. And there's a bunch of answers, but the simplest one is because I can. Which is funny, but honestly, I chose this because it's a huge educational endeavor for me. I'm not a great programmer. I can code. I'm not the best at database management and aggregation and all that stuff, but I've done it. I am extremely interested in the analytics side of data, data visualizations and things like that. Obviously, I'm a big fan of open source and stuff and managing open source projects. So it was like, this was like a collective thing. It's like I can tackle a lot with a single project. And it'll give me some focus for 2015. And so that's really what the reason was. It's not about the project's really cool or anything. It's an exercise in vulnerability. But as I said, there's already projects that come into this in some form or fashion. So why reinvent the wheel? In this case, I don't feel like I'm reinventing the wheel. It's more like a Lego set, where you buy a Lego set, you get a set of instructions, you use these pieces to build this. Well, all the hackers and us were like, yeah, that's cool. No, I'm building a transformer or something like that. It's using some of the same baseline components. It's the same kind of overall objective, but the end result is completely different. So, like I said, Harbinger is a wireless sensor network project for historical trend and predictive analysis. It was cool just to write the sensors and be able to see all the stuff that's in the airways, but I wanted to have a practical application and stuff. I want to be able to actually extract information and intelligence out of the data that we're collecting. Unlike other sensor projects, Harbinger is completely passive on the airway. This was the number one differential between a lot of the projects that I've worked with and stuff, specifically Snoopy and Snoopy NG, is where they had, it's a active sensor network, meaning they actually directly interact and force interactions with clients, where I wanted to take a complete step back and just be able to observe what's going on in the airways without any interaction, because it's a more pure data set in my opinion. Also, Harbinger is an actual open source project. It has an open source license, unlike most of the other ones. And you can get into legalities of open source. If it doesn't have a license, the copyright still is held with the company or the person that created it. I chose GPL v3 for several reasons. Of course, you can get a license to debate, it doesn't matter. But this was my choice. So the code is completely available. You can do whatever you want to do with it under the permissions of the GPL v3. Some of the requirements, it has to be open source. All of the components, there's going to be 3 major components of the project. There's only 1 right now, and we'll talk about the additional components. All of them will be open source. It must be hardware agnostic as possible to keep costs down and allow people to use whatever hardware they have available. I'll go ahead and tell you I failed at this in my first attempts, and we'll get into that a little bit. Luckily, I'm fairly intelligent and figured out how to solve my own problems. Keep dependencies and requires to a minimum. This was important to me. I've done a lot of, in the open source community, it's like, hey, download this cool project, and you spend 45 minutes installing dependencies and all this other stuff and compiling a bunch of stuff just to find out that you don't have the right version and it doesn't run. So I wanted to keep that to a minimum. And also, the last thing, it must scale. I envision a 10,000 node sensor network. Is that ever going to happen? Absolutely not. Simply because in order to deploy 10,000 nodes, you're pretty much going to have to be a company or really, really rich or something like that, and it's just not feasible. But I want to design a system that can support that. So from 1 to 10,000, and starting the process of designing something that scales from the beginning helps. Project breakdown. There's 3 primary components of the sensor project, which breaks down into stages of developments. The first one is the sensor nodes, when that's mostly what we're going to be talking about tonight. The centralized data management. There again, we've got a bunch of nodes. We've got 10,000 nodes deployed. We need a way to aggregate that data and process that data. And the absolute most important stage, in my opinion, is the analytics and data visualizations. Being able to use the data that we collect for some purpose, whatever your imagination will come up with. So stage 1, we're dealing with the sensor nodes, and that's where we are today. The node requirements are fairly simple. You need to be able to run Python, specifically 2.7x, whatever your version, SQLite, a wireless interface that supports monitor mode, and that's it. It's pretty straightforward as of right now. There will be one additional requirement that coming in about the next 10 days. It's along the Python, but you will have to install or compile PCAPI depending on which platform that you're running. But it's a minimal requirement and dependency. But what it'll actually do is increase the efficiency of the code, specifically on low hardware or low power hardware such as the Raspberry Pi. PCAPI. It's a library extension for Python, specifically for parsing packets, either on the wire and in this case, pulling it from the monitor mode. You can do it in native Python. We're in native Python with this current iteration. It's just not as efficient. It's having to churn through a lot. So like on a Raspberry Pi, you're at 100% CPU utilization.
It's based on the PCAP.
It is. It's based on, it uses libpcap as well as some other bits and pieces to make the native Python more efficient. So, but we're not quite there, hopefully in the next 10 days. But in order to incorporate PCAPI, it's basically a complete rewrite of the initial code base, which is not that big. Hardware platforms, here again, I try to make it as agnostic as possible. There are some caveats currently. Raspberry Pi A, B, B+2, doesn't matter. As long as you meet those minimum requirements. BeagleBone Black. I've got the TP-Link MR3040 here with a little asterisk because this is where I screwed up. Turns out that all wireless drivers do not handle monitor mode the same in terms of parsing packets. So when my objective of having a hardware agnostic system, it actually only works on 2 chipsets currently. My bad. Realtek 8187 and a random Atheros chipset. Not Intel, surprisingly. It doesn't work on Intel. But PCAPI actually, it actually will solve a lot of these problems. So, and the reason why I put the TP-Link MR3040 on here, in order to run any of the other hardware platforms, just having the hardware itself is not enough. You've got to, like in a Raspberry Pi case, you've got to have a power source, you've got to have media, you've got to have a wireless antenna. So trying to keep the cost down, you're already about $50, which is still not bad, but it could be cost prohibitive. Whereas the ideal platform is actually this little device right here. This is the MR3040. It's a battery-powered, self-contained wireless router running OpenWRT. The only drawback to this is it's only got 4 megs of flash, so you do have to use a USB overlay file system. Not difficult to set up. Once I get the chipset issue figured out, all the documentation for this exact platform will be published. But like I said, I can sit here and turn this on and deploy it anywhere. Just on the stock battery, I get about 5 hours of detection. So if you're doing a short-term deployment, there's nowhere you can't hide this. I mean, it's good luck finding it. And like I said, it's completely passive, so nobody will be able to detect. If they're listening on the airwaves, they'll have no idea that you're also there. $35. So it's cheaper than the Raspberry Pi. It's cheaper than the BeagleBone Black. It does suffer some. I mean, it's only a 400 megahertz processor, so more likely to potentially miss a few bits of data and stuff like that. But in the preliminary tests that I've run with PCAPI, I'm able to hover about 80% CPU utilization, which is awesome on this type of platform. Question?
Battery?
2,000 milliamp inside. Yeah, I'll show you guys. It's just a cell phone battery. Yes?
A 6K USB, could it support massively on a 4G?
Yes, this particular router does have, there's a lot of awesome things. I use this router for a lot of different purposes. This is my pocket pen test. It has a 3-mode hardware switch that allows me to program different configuration options and stuff. So depending on what my type of assessment I'm doing or whatever, I can literally just set the mode. And the default mode in the standard router is 3G, 4G, WISP, and 8. But I can actually want to be in a pen test mode. I just put it in the proper hardware switch location, turn it on, slide it in my pocket, and I'm a walking pen test, and pivot box and stuff like that. So you can use the 4G. In fact, there's I think it's Hawaii. I think that's how you pronounce it. They make a 4G dongle that has a micro SD card pass-through. So you put your file system and your code on the micro SD, plug the whole thing in. The unit's about this tall. There again, it's still really easy to deploy. The one thing you will have to take into consideration for that is your power consumption is going to be greatly induced. Specifically right now, I haven't incorporated any kind of 3G, 4G backhaul or anything. One, because that increased cost, and two, for me, right now, we're still focusing on a completely passive system. I could actually, with this particular model, I can do monitor mode as well as client mode simultaneously. So I could actually jump onto an open network somewhere and actually backhaul the data if I wanted to. But right now, that's not an objective because we're wanting to stay completely undetected and not utilize somebody's infrastructure. In terms of wireless adapters, right now the best option is anything that's got a Realtek 8187 chipset. So some of the older Alpha cards, different things like that. As soon as I get the next iteration of the sensor code, TP-Link WN722 will work. Most of your Athros 9K and 7Ks will be solved with the new version of the software. So you'll basically be able to run almost anything. I do think some of the raw link cards are working on the chipset. I just haven't got to completely test those out and stuff. But within about the next 14 days, we'll have a fairly agnostic system. So whatever you have in your toolkit, you'll be able to run. These are just some of the data requirements. One of the things that's important for me is that we don't capture a ton of data. We need to capture very specific data. And so one of the things we're collecting is probe request, the data client, the date and time that a client appears in the network or on a specific node in the network, when it was last seen by the node or network. Also, we need to capture all the access points that are in the vicinity of each of the nodes and the networks. And also in the next version, and I've already got the proof of concept for this running, is we're going to be capturing the signal strength from the clients because that fits into our triangulation model and it algorithms really, really well. And based off the math that I've already been able to hash out and stuff, I can predict east, west, north or south within about 3 feet of the access point where you're at. Simply off of these data points and some other information. So this is the way the data scheme looks right now. It's just saving into an SQL-like database on each node. This is going to change slightly as I add the RSSI as well as multi-node deployment. There will be a node ID on each of these databases and stuff for when we do the data aggregation, but it's really simple. The miscellaneous is there, and just in case we're catching we're getting malformed packets or something like that we might be able to pull information out, but there's no telling. So it's really pretty straightforward. Nothing. Let me iterate that we're not collecting. I'm not doing full packet captures. I'm not looking at where your device is browsing to, if it's on Facebook or anything like that. I don't care about that. Some projects do. I don't. I simply want to know I want to know if the device is in the network and where it's at in the network. That's it. So in order to get started on this project, you have to get the code, which that's funny if you ask me. Spent all night on that one. No, the thing about it, Huntsville, no, like half the room got it, and they were all just like, eh. I thought it was brilliant, but I mean, I am biased. So it is on my GitHub account. You can go clone, fork it, whatever you want to do. If you do go and start playing around with it, and you find issues, and you're going to find issues because I wrote it, submit pull requests, we'll get them fixed. We're working, actually, I've got a gentleman that he was just all up in arms about this project, thought it was the coolest thing ever. He sent me the preliminary code for importing all of this data into that project. Say data collection system. I can't. My mind's blowing. Splunk. That's it. Yeah, actually pulling all this data into Splunk from an enterprise perspective, which has some interesting possibilities and stuff. So the what? Not yet. Maybe.
That was going to be my question. I know Elasticsearch is really big with a lot of people who used to be crazy about Splunk.
Yeah. It's actually something I never even thought about. Like, he was like, I want to do this in my environment. I'm going to incorporate it in Splunk, and I'm like, submit the pull request, and I'll put it in the upstream patches. Because for me personally, I don't have a need for it, but this isn't just my, like, yeah, obviously I've started this project, but this project's just not. It's not just mine. It's whatever you can make it to be, and this is part of like my open source spiel that I'll get onto. If you write something, publish it. If you find a solution, publish it, because it's not up to you whether that's the solution for me or not. It's my choice. But if I don't have the option of using that solution, it's hurting me and it's hurting everybody else in the community. So write stuff, no matter how bad it is, put it available. Somebody will find it. Somebody will be able to use it. But basically, to get started, you just clone it, CD into the Harbinger directory, and you can run the shell script. The shell script is specifically, the biggest thing that it's doing is actually setting the monitor mode interface using ifconfig and like IW. If you've got Airmon NG installed as part of the AeroCrack suite, which most of the hacker types, that's just a default in all of our systems and all, you can just manually do your interface. If it's not Mon 0, you will have to go into the actual sensor code and choose which interface you want to do. This is just a snapshot of what the actual sensor code looks like. It is written in Python. This is native Python. No exorbitant libraries and extensions and things like that. The next iteration, like I said, will require a PCAPI simply for efficiency, and it just makes the parsing process a whole lot cleaner, in my opinion. Yeah, so it's not much to look at. I had a lot of help. The actual original code base was provided by a gentleman named Adam Byers, who wrote a program called Wireless Client Tracking Framework, which obviously there's a lot of correlation in those and what I'm trying to do and what he did. So he was gracious enough to give me his unreleased code for his project and allow me to make a lot of customizations and stuff like that. So yay, open source. Another important component, there's two primary components of the code. You've got sensor.py, which is the actual software that's running to do the data collection and things like that, and the db.py is what we can use to visualize the data, or to actually see the different sections of the database and things like that. This is just a way to quickly query the database for results and things like that. And so the output of this is node.db. This is part of a scan that I ran standing on the side of the road in Huntsville, Alabama at about 10 o'clock at night.
Well, that's not sketchy.
No, yeah, I looked like a really like fat, messed up Statue of Liberty because I was holding a Chromebook with an alpha and an antenna like this for like 5 minutes until the cop came by and hit his brake lights, and we're like, all right, it's about time to leave. It's just like, I don't want to have to explain to the cop exactly what's happening, because it's not illegal, but cops are not going to understand what I'm actually doing. So I don't know how well you can see this, but this is some different information that we've got. Here we've got a section of probe requests. We're seeing who sent the probe request, to what access point or to what SSID that they're looking for. We're capturing the number of packets, and here's the timestamps in which that's happening. Here is the access points that we've detected in range of this sensor. And there's very interesting information that I determined in this. There are a lot of cars that are broadcasting unnamed wireless networks. Not hidden networks, they're just unnamed. If you see these NAs, that's all of them. In a 5-minute period, I captured 78 clients on this highway, so cell phones driving by, and 195 access points. The thing about it is the access points that I found, most of them were only sending 3, 1, 11, 6 packets. All of them had NA. Started diving into the video of when we were doing it and looking at the types of cars that were going by. There's a lot of Audis that were driving by. There's a lot of BMWs, new Fords, which is really interesting that there's that this data kind of supported. If you look, there was a report that came out yesterday from one of the senators just attacking the automotive industry for not essentially building security into their systems and how vulnerable they are to hacking. This evidence really goes to support the fact that you've got networks that are just broadcasting from these vehicles.
A lot of those are probably going to be commercial 18-wheelers, because especially those who have commercial dispatch.
Not where we were located, though.
Didn't see any 18-wheelers.
Not in that 5 minutes.
I've done sniffing while doing long interstate drives, and I found a ton of
I find it a lot, but specifically where we were at, I have zero recollection of any 18-wheelers or big rigs at all. It was mostly just standard traffic. Not at 10:30 at night. Yes.
Yeah, I saw on the news yesterday, last night, where hackers were able to apply brakes to these cars.
Yeah, there's a lot of issues in the automotive industry from a security standpoint, and I won't get into all of those. Part of the issue is a lot of them have we've separated the networks. We've got network segmentation, except you have central points in the system that can talk to all the networks. So you're still, if you can ever get into one system, you can essentially VLAN traversal, if you want to call it that, into the actual system networks and things like that. Yes.
One thing that I think is some technology to look at, cars are trying to talk to each other and you can from it and stuff, so having all up there wrecked by the inside.
Yeah, so what the comment is for the people that are watching online or watching later, is that there's a big initiative in the automotive industry to kind of make self-aware cars that are able to talk to other cars in terms of being able to figure out reaction times and things like that, so that cars can become somewhat autonomous in their driving, and they're using a lot of wireless technologies and things like that to do these communications. Some of them are low energy things, more like I've seen some research for actually using like XB or Z waves for these communication systems and different things. As we introduce this technology, we're gonna see major issues, because most industries are solution driven, and then we'll deal with the security after the fact when something goes wrong. But getting back to this type of data here, this is, like I said, this is just the client MAC addresses. The number of packets that we were detecting. and the timestamps and things like that. So this is basically all the data we're collecting. Not a lot, not completely invasive in terms of your privacy and things. Not a lot of specifically identifiable information because frankly I don't care who owns the device. I just want to know that the device is there and I want to be able to see what the device is doing. So you've created a node or nodes, and now you want to deploy them. And this is the hardest part of a sensor network. Just as anytime you're implementing wireless infrastructure, there are certain checks that you have to go through. You know, one of the things you want to do is check for like interferences and stuff like that, and turning down the power, transmission powers and stuff on your radio so that you're not bleeding out to, you know, people a half a mile away. While we don't deal with the same issues in a sensor network, there's some commonalities and there's some things that we have to take into account for. The first thing is, do you have to have 100% coverage? Anybody got an idea? You don't. You simply do not have to cover 100% of the area, simply because of mathematics. We have the ability that if we are able to cover the what I call choke points, meaning entrances and exits to the grid, making sure that those are covered, as well as some internal points of interest, then we are able to extrapolate all the data out mathematically as if we covered 100% with a fairly high accuracy. Questions that you need to consider when you're deploying your networks, because once we're all done here, we're all going to go do this. And y'all are all going to send me the data. Where are your choke points? You got to figure out how people are going to enter and exit the area that you're wanting to cover. If it's if you're actually covering like city blocks, your choke points are going to be the primary intersections to get in. If you're covering a campus or something like that, parking lots, building exits, let's take a mall. You just need to cover all the doorways. If somebody can walk into the mall, there needs to be covers there. Yes?
In a typical enterprise, bathrooms are a great place.
Yeah. I'm not going to put that one on. I'm not going to say that on camera to go online. But yeah, you're absolutely right. And things like that, things that you know people have to go through, they have to traverse, so it's a non-optional. And this is going to allow you to capture the highest percentage of data. Another thing that you need to look at is, can a device be seen by multiple nodes? This is really important for data calculations and accuracy. If I've got a device that shows up in only one node, okay, that's cool. I've got some points of data that I can process and stuff like that. But if a single client is detected by two nodes, now I have two hard-coded points of reference, which increases my accuracy a lot. And so you don't have to have node overlap unless you can afford it. But it's something you want to take into consideration depending on how accurate you want the data and stuff. And also something, you know, if you're looking at a long-term deployment, what happens if your nodes go down? One of the things you can solve is by what I do classify as a 2x3 deployment. So you use 3 nodes to cover the area that 2 nodes can actually do. So you've got enough overlap that if one does go down, you're most likely not missing data. But here again, that's not exactly cost effective. So you've got to weigh all those factors, like what can you afford, how many sensors can you do, where we need to put them, and things like that. So you also need to figure out how expansive your actual coverage area is. This is a few city blocks in Asheville, North Carolina. It's not a super big area, but it's big enough that it can cause, you know, some deployment issues. There's a lot of factors that you're going to have to take into play. Topology, material composition of surrounding buildings and structures, stone, steel, glass, concrete, will affect the effective range of detection on each of your sensors, but we'll get into that in just a second. So the first step to deploying any nodes, before you actually go, I'm going to do my first deployment, is you actually need to survey the landscape in terms of what the wireless infrastructure is already in place. Specifically, we want to know every access point that's in the network, and we want to know its exact GPS coordinates. Because this data is going to allow us to fine-tune the placement of our nodes. And you can use Kismet, Wiggle, whatever your GPS software of choice is. For me specifically, I like Wiggle a lot. I think it's a fun project. And essentially, what our project, or my project is an inverse Wiggle. Wiggle is designed to capture cellular towers and wireless access points. Mine's designed to find the clients inside of those access points in those networks. So determine your exact area that you need to cover. Estimate where your checkpoints are in the grids that require coverage. You need to test a sensor at each point, looking at the access points that are within range of the sensor. So I go to my first choke point and I deploy a sensor. I run it for 2-3 minutes. It doesn't have to be long. Because it's actually a fairly efficient system in its data collection. And then I need to look at all of the access points that it detected in that range. Because what I can do is I can cross-reference the access points and the BSS IDs that I've captured with my Wiggle or my Kismet data. And what that allows me to do is it allows me to calculate an ERD, the effective range of detection. So given a specific geographic location and a specific hardware configuration, I know exactly where the outer limits of that sensor is. And it's going to change even from location to location because of all the environmental variables, but understanding what the threshold of that is the most important thing. So in this case, what we're just doing is we're taking the sensor output, overlaying against our previous scan, and we're finding the common points. And once we reach a point where there are no common points, we can draw our boundaries there and go that we've got to make sure that this sensor is placed, that this is the effective range, and this is where we're going to deploy it. Yes?
What kind of fun could you have? Let's say you could use 23 dB sectors on high locations.
So the question is, what kind of fun can I have if I use like 23 dB sectors on high locations? And the answer is that is a hell of a lot. The problem with that is there comes a break point where you actually lose efficiency. One of the things here, let's go back here for a second. So we've got a fairly rectangular area that we want to cover. What if I just took, assuming that we had 90-degree coverage on these antennas, just put one at all 4 corners? More than enough power to actually cover the distance and stuff. The problem with that is I actually lose points of accuracy. Because my nodes are further apart, there's a much greater potential for deviations within the path. For example, so if I've got a node here, node here, node here, node here, I'm not going to actually be able to necessarily see a vehicle or a device move in this path. I'm going to know they're in the network, but I'm not going to actually be able to see specifically the exact routes and actions. Okay, so there comes a point where and I don't know what the magic formula is of having more data collection points versus just being able to provide the coverage.
Now, in that four access points, with four access points at each corner,
Mm-hmm.
especially once you get the RSSI implemented, could you not triangulate and get a
within a halo?
Within a hot zone?
Within a halo hot zone. And obviously, especially if the 4 access points that we're talking about are powerful enough to essentially cover the entire grid themselves, or within, this one, be able to basically cover this entire area. It doesn't have to cover anything.
I can tell you right now, you get a 23 dB sector,
Yeah.
and you pick up 4 or 5 miles.
Yeah, so there's going to be a lot of overlap. So in that case, you do get a little bit more accuracy, but you're still not going to be able to get the exact path they traveled, because what you're essentially going to do is have radiating arcs, and if you do the math right, you could probably get the same level of accuracy. I'm not a mathematician. So that's one of the things. If you want to provide me the 23 dBi sectors, I'll do this, and I'll get you the results. Okay, we'll do it together, and we'll have a lot of fun. We probably won't be able to publish the results, but we'll still have a lot of fun. But yeah, and this is something that's important with this project is it really comes down to your use case. If you have the hardware, here's the thing, you start putting up these massive antennas, you're going to start drawing attention. I mean, it depends. You know, it ultimately it depends on the actual objective that you're trying to do. You know, this is much more, you know, this is easier to hide, to deploy rapidly than actually having to climb up on a tower or erect a tower and stuff like that. It all depends on what your actual objective. But to answer your true question, can you do this? Absolutely. And I really. I'll get to that if you don't mind in just a moment. Yeah, so basically what we do is we do an overlay of Wiggle to look at the access points that we can see, and this gives us a geographical region that we know our sensor can operate in, which honestly, for me, I was struggling with figuring out where do I deploy the nodes, like how frequently and things like that. Coming up with the solution of using essentially geo waypoints tied to the access points, me personally, I thought it was kind of brilliant. Being able to, because I can't sit here and deploy a node and run 500 meters or whatever and see if it can still see me and then run back and check and stuff like that. This way it gives me a really easily, if I have the wireless survey ahead of time, I can pretty much fine tune these nodes while I'm deploying it. So it's a very effective system, and I think it's a little bit of a ingenious system without having to get into a lot of deployment issues. So the results of by being able to calculate the ERD is you're able to place your sensors in much more strategic locations because you know how far they can cover. In this case, it's about a reduction of about 30% of the sensor, and that's just an estimation based off of what I know the effective range. One thing that's really interesting about wireless, once you reach a certain RSSI, your wireless internet is useless. But for me, for this particular project, the usable RSSI that we can detect is a much greater. We have much greater range because we're simply listening. There's no transmission. There's no interaction. We're not having to maintain a link or anything like that. So whereas the effective wireless internet range of this may be like a 35-foot radius, I've gotten almost 100 feet out of this one radio that I've actually been able to detect. And that's a 100-foot radius. So it actually, because it's a completely passive system, it makes our radios, it uses the radios at a more efficient level than having to try to maintain an interaction between client and access point. The ERD is highly environmentals, barometric pressure, weather, material composition is the big one that I found, as well as existing radio, RF interference and stuff like that. So one of the things is that you will have to, in an ideal scenario, you will be constantly kind of testing your data against your current node places, and once we get to stage 3, there'll be a means of doing that, of kind of honing in is our node placement still the best location based off of the data that we've got, and we can and the data that we know we didn't get. So stage 2 of this project, there's not a lot to say about it yet, simply because I haven't got to that. I'm just now starting that development stage. But this is simply a mechanism and a process for being able to centralize all of your node data into one aggregate system for the ability to process and run analysis and stuff like that. It's not a sexy stage of development, but it's absolutely necessary. One thing I can say about the centralized data management system and going into stage 3 is eventually I will actually sanitize all of the data that I've got, and you will actually be able to run analytic queries yourself on the entire data set. And I'm going to design it in a way that people will actually be able to submit their data in a sanitized format. So for being able to look at different geographic regions and stuff. Yes?
Plan to collect the data twice.
So there's a couple of different ways. Part of it's going to be depending on your actual infrastructure in terms of what are you using for the nodes if you're using Raspberry Pis and stuff. But what's ultimately going to happen in this particular case is there's going to be a 3G, 4G backhaul, and it's just going to sync the data to the centralized data. But in this, like if you're using this router, I can actually connect this to an existing wireless network and do the same thing. Now, with a iteration that's currently being tested and messed with, there is the option of using XB for data synchronization. Now, what you would require is you would actually just drive through the network, and as soon as your XP transceiver got into the proximity of the nodes, it would just automatically start downloading the data. It really depends. It's depending on if you really want to get called and have anything to you, because, like I said, for the time being, this is a legal system. Not legal for companies and not legal for law enforcement. This is a direct violation of the Fourth Amendment from a law enforcement perspective.
So not legal, but who's going to stop it?
Yeah, I mean it's one of the things that it's the illegal search and seizure by law enforcement. They can't do this, but I'm pretty sure they're doing it in some capacity. And
It's already tracking license plates. This is just.
Yeah, this I'll actually give you a little bit more information. But yeah, so centralized data management, but it's going to be necessary, and that's the next stage of development that I'm going to be working on. This is where I get to have the most fun. And this is going to be the most challenging, and it already has proven. I lost about 3 days of development because I actually found how I'm going to do all of this through a tweet, and I jumped down a rabbit hole, and 3 days later I'm like, oh, this is crazy, but I actually got to finish stage 1 first. Well, to actually finish this platform, I'm looking at release of Harbinger in October, and that's going to include all the sensor code, including instructions, scripts, all of the necessary for building out the sensors, the data collection and management system, as well as the open source visualization and analytics engine. So it's a year-long project for me, but this is my teaser for what it's going to. One of the visualizations is going to allow us to see specifically, and I have sanitized this so there's no data in it or at any point. But what we're going to be able to do, the nodes are going to be deployed in groups. It'll be a network, a group, and then individual nodes itself. And so what this map is going to allow us to do is select our regional network, drill down into specific group sets or a specific node, and actually look at the data that's happening around that node in near real time. So when you zoom out to the group, you're going to see a cluster of nodes, and you're going to see all the data points, just trotting about, driving through, or whatever. And then you can do that from a global networks perspective. If we could deploy it in the entire United States, it would just light up, and you wouldn't be able to decipher the data. But this is one of the things that I started. And what's nice is if you look at the top, you're going to have the Data Explorer. Right now, this is just going to be a way. It's a means of actually searching the data for specific BSIDs. SSIDs and MAC addresses and things like that. But there's also going to be an element to this that's going to have the ability in the actual published version of my visualization engine that will contain all of my data sets. You'll actually be able to run queries, submit algorithms and things like that to run analysis and get output of it. So I say coming soon. The reality is we're probably looking at mid-October for me to completely finalize this. I actually do have a proof of concept that's actually working, but I refuse to show it to anybody until October, just because it is really, really, really cool. One thing I can say, is anybody programmed in R? Okay, I have 3.5 days of R experience, and it is the most awesome language I've ever dealt with for statistical analysis. In fact, what you're seeing here is actually a web application that's written completely in R. But there's it's a steep learning curve for me to jump into a new language, to a new visualization, all that stuff. But heck, why not? You only live once. But it is really, really, really impressive. And this specifically is using an add-on into R called Shiny and Shiny Dashboard, which is basically what allows us to create the web-based application based off of all the R code. And it's a really interesting language. It's not hard to get started in, and it may be a future talk that if anybody's interested in, because one thing is the primary IDE for R is RStudio, and it's open source and cross-platform across all the major operating systems. So that's really cool, really easy point of entry to get started. So that's basically a breakdown of the Harbinger Sensor Network project. By the time 1.0 release comes, there will be some verbiage change. We're going to, because it is a sensor network, but more and more that we've jumped into it and I've started looking at it, this is actually a wireless intelligence framework. And you can, if you understand like what intelligence data and things like that, you'll understand the application of this. Yeah, so any questions, comments, haters need not apply. So anybody like it? Hate it?
Yeah, I think it's very interesting.
Yeah, I mean it's an interesting thing. It's one of the things that I have to kind of have a fine line with is what the actual objective of this project is, because is there the potential for somebody to take this exact code, not modify it, just keep the data, use the data in a different form for something evil?
THA.
Yes. Okay. In fact, that's where the entire project started. Is essentially the idea from when Zombies Take to the Airwaves was a wireless surveillance network. Now, it wasn't designed that way. It was just a regular infrastructure, wireless enterprise infrastructure. But if you look at the data that you can see, even from like Ubiquity and all that, looking at all the amounts of information, all the information we've collected is right there in your enterprise console. It's all there. MAC addresses, APs, rogue clients, who they're talking to and who they're trying to talk to. That's it. And what time they came, what time they left, when they were last there, and stuff like that. This is not new stuff. It's just a twist on how we're utilizing the data. As far as the real world application that you talked about, specifically the end goal for me is to be able to analyze deep subsets of traffic analysis, and which is a mouthful of stuff, but basically what it means is in a predefined ecosystem, such as roads, finding the tendencies of traffic patterns and things like that, where people are taking shortcuts, where people are actually speeding, because I can figure this data out because I've got access. I've got 2 fixed nodes on GPS, and I have timestamps. So yeah, I can actually calculate how fast you're going, which direction you're going, all of these things like that. This is why I said it is a wireless surveillance network. It's just not my application. Yeah, I learned. Here, let me dip it in the water. Yeah, so, but inherent with the data that we've collected, it doesn't look like it's that harmful or anything like that. But when you start running the mathematical processes on it, of being able to go, I saw you at this time and I saw you at this time, and these 2 nodes were this far apart. Well, speed is time over distance. Guess what? We just calculated that and stuff. So there's a level of creepiness to this. I fully admit that, and I'm okay with it, because I could have made it a whole lot creepier. But yeah, so the actual applications and stuff is really, there's some fluid dynamics applications, because traffic analysis is actually just a fluid dynamics, because most people don't understand traffic as we know it actually acts like a fluid. And so being able to, but finding the micro levels of information, not just the surface is like everybody's traveling this road at 4 p.m. Don't go down Pelham Road at night unless Google tells you to because there's an accident. Being able to employ environmental variables such as cross-referencing real-world events, such as, let's say there's a red light outage. Well, most of the time we have no data to back up how people actually react in that situation. Based off of being able to pull a subsection of the time and the specific location, we can actually get an idea of how people are handling this obstacle and stuff and the tendencies. Are people actually treating it like a four-way stop, or are they just being idiots and things like that? So there is actually some real-world application in terms of data analysis, looking for efficiencies and things like that. Also, you'll be able to see divergence as people are anomalies within the data. It's like normally this is the path that people take, and all of a sudden there's a lot of traffic in an abnormal area. Well, from that data, what we're going to be able to actually do is go and find the root cause by looking at other data sources, like, oh, this is an accident and things like that. Understanding how people navigate in a controlled system when unexpected environmental variables come, such as an accident stuff. Or is the majority of people taking this road, or is traffic just backing up? Do people know actually how to navigate within that closed system? Or are they creatures of habit and they're just going to hammer home and things like that?
So I've got a question on the data storage. So each device writes to a local MySQL database, correct?
It's a SQLite right now.
Okay, so if you had a semi-reliable or reliable backhaul, could you not use something like zero-in-queue to fire off messages?
Absolutely, absolutely, and that is something that I'm looking into. There's going to be different iterations of the project depending on what your actual configuration is. For the time being, it's like keep it simple. Don't rely on having to have the data, a backhaul or anything like that. To actually do a real-world deployment, you have to have the backhaul. You're not going to drive around and do stuff like that. Another thing that's cool, though, is there's a version of this code that has not been released that actually contains GPS functionality, which means if you're running it on a rooted Android phone or tablet, that you can actually have a mobile sensor, which mobile sensors really, really are interesting when you add it into conjunction with the static sensors, because the amount of increase of information that you can get is really, really awesome. So if you've got, for example, you're using you're in a municipality, a city that has like meter maids, like the little golf carts like Greenville does. Put one of the sensors on the golf carts, because what you're going to get is you're essentially just going to get a moving point, but because you have the GPS coordinates at a specific time, it's like a static point. So you're going to be able to run a lot more correlations. There's a lot of data that you can do with actual device correlations, meaning that you can pinpoint the fact that two people were in the same room at the exact same time, week after week after week. That's a little creepy. It starts to get into the surveillance stuff, but I'm just providing you the data. Whatever you want to do with it, that's up to you. I'm not liable for any of it. This is just a research project.
It's no worse than what any government could get by subpoenaing a cell phone company.
Absolutely. Yeah, they can get a lot more. The good thing is the difference here is okay, even getting GPS information still is a like if a law enforcement wants to track my specific phone GPS and stuff, there's still a couple of hurdles they have to go through. Theoretically, okay, and stuff. Here's the thing, if I want to go and track Jeremy's GPS on his phone, there's ways to do it. It's going to be very expensive and time consuming, and I'm probably going to have a lot of people showing up my door asking me what I'm doing. Short of the feds that have heard this presentation and the bots that will find this on YouTube and places like that, nobody knows that it's even out there because it's completely passive. And so, like, if it's one of those cases where you actually happen to own like a massive, wireless ISP backhaul that all of your nodes can jump into, hypothetically speaking, You know, if you can just slide me those passwords, then, you know, I'll get you some real data and stuff like that.
Do you have any commercial aspirations?
Enterprise software.
Yeah, so
I'm not going
so I missed. There's one thing that I hit big time in the previous talk when Zombies Talk to Airwaves, is that there is a multi-billion-dollar company in retail analytics. They're doing this just in smaller scale. Most of them are doing like, you know, 1 or 2 sensors and stuff. But what they're looking for is the exact same data that we're talking about. They're looking when a person comes to the store, if somebody went by the store, when they were last there, what areas of the store they're going into. And so there's already a commercial entity for this. Just most people don't realize that it's actually taking place. And so this part of this is bringing transparency to that, hey, this is possible. And your devices are, you know, if you're leaving your wireless on, you're a victim, number one. That's part of the reason why I'm not actually demoing the code here right now, simply because I don't want to get all of your permissions and I don't want to piss off a Medion and anything like that, because ultimately I don't have any PII, but it's not hard for me to take one more step and actually figure out that's your phone and things like that. So,
well, I have an idea about people's devices. We run the public network in downtown Pickens, and we see about 10,000 unique devices a month connect to our network. And, you know, we use Ubiquity, and we can go to management software and go back a year and see specifically what MAC address is connected, how long they connected, when they connected.
But you're not also just seeing connections. If you can set it up so that you can see any client that interacts with the access point.
The management software that Ubiquity makes,
Mm-hmm.
we cannot see, we can see rogue APs.
But not clients?
We cannot see rogue clients.
That's easy to fix.
Clients that connect to the network.
Okay, yeah. So, but even at 10,000, and you got to figure that's a small percentage. Yeah, I went to Pickens High School, so I know exactly what you're talking about. A bunch of rednecks and trucks. Yeehaw! I got my PhD though, Pickens High diploma. What now? No. But yeah, so this is not information that's new. This is just a slightly different spin. This is how you can do it yourself. One of the interesting projects that came out of my talk last year. Is anybody familiar with Tim Tomes, author of Recon NG? If you're not in security, you probably don't know this project. Anyway, it's really cool. Open source intelligence gathering platform or whatever. He's from Spartanburg. He needs to show up here one time and do a talk. But he was in my talk, and they came up with this idea of using this whole concept of being able to just monitor the airways for proximity. He actually came up with a proximity detection system. He calls it WUDS, it's Wireless User Detection System, and he set it up at his home, and he basically has like a 30-foot halo around his house that if anybody enters that halo that's not on the whitelist of MAC addresses, it sends them a text message notification. So he can determine if people are on his property and things like that. There's a practical application using wireless for actually in terms of personal surveillance and security. Because guess what? People don't turn off the wireless on their devices. And I don't know, in this age of GPS coordinates and wireless technology, there's a real simple, it's not a complete fix, but there's a great patch that we can implement to make a lot of this less possible. And it's as simple as like, okay, I go to my house, I take a new phone, and I connect to my Tim's Super Awesome network for the first time, and I can see my phone knows the GPS coordinates. It knows where the phone knows where it's at. So why not simply figure out a mechanism to append a waypoint to that network information that's stored in the phone? And once I leave that proximity, it automatically turns the wireless off. And the next time I go somewhere else that has Tim's Super Awesome network, guess what? I'm not at the geographical location, so my wireless doesn't connect unless I manually get it to connect. There are applications that do this, but it's not by default. Yes?
I run tasks on my phone. It's a
That,
Kind of a supervisor that lets me control all kinds of things. I do exactly that.
yeah, so it's basically what you're doing is you're managing your wireless radio simply by GPS locations. This cuts down on rogue access points attacks like you wouldn't believe, because all of a sudden you're at your work and the Starbucks network shows up because I'm on a pen test. Guess what? None of your devices are going to connect to that unless you manually tell it to do it. So it may not be a perfect solution, but it definitely would eliminate everything that I've just talked about. Like, you just couldn't do it.
Talking about turning off the wireless, like the Wi-Fi or the 4G.
The wireless. We're specifically talking about 802.11. Yeah, because I can't legally do anything with the 4G.
See, the 4G, you can, theoretically, it would be detected, so.
Yes, you can detect it.
You're walking around with your phone on.
Yeah, you could do the same thing. The problem is you're going to have a device that's tuned into those frequencies. Now you could use, I don't know what do you know what the frequencies of like LTE and stuff are?
700, 2100, 1600, 2500.
So easily detectable with a hack RF?
Yes.
Okay, yeah, so you could actually modify this code to actually run on any frequency that you want to. So you could detect those like LTE bands and stuff. I wouldn't.
But here's the thing, 802.11 sends a lot of this information in the clear.
Yeah.
That is the LTE protocols to do that.
No, I'm not looking at it in terms of that point. Is what we'd be able to do is just look at the specific burst and like, is there communication taking place? Is there a frequency? Is there anything happening on that? Which would give you the proximity. You wouldn't have any insight into the data as to what's happening, but you could go, yeah, there is communications from something on this band within my detectable range.
And fault detectors triangulate the location as well.
Yeah, it'll be a little bit harder, I would think, simply because you don't have a lot of static geographical waypoints, and I don't know how to calculate the signal strength in those bands and things like that. I'm starting to get into it, but yeah, theoretically you could. There again, I just don't want to play around in licensed spectrum.
It's doable, but for using a hack RF, for instance, you would need multiple ones. For example, because it doesn't have a large enough operational bandwidth for LTE, it's got about 20 megahertz operational bandwidth. So if you had multiple hack RFs with directional antennas, all that's possible. You could triangulate just as well as a cell phone company.
One of the problems you would have, though, is frequency hopping. You know, every so often they swap frequencies to a different set, so that helps.
Yeah, and that's one issue that we actually have in this particular setup, is because you do have frequency hopping within the clients, within the access, well, not in the access points, but so I'm not able to monitor all 13. I guess it's 11 here in the United States, all 11 channels simultaneously. So what it's just doing is quickly cycling through those. So in order to capture 100% of the data, I would basically need 11 sensors in each location, which is not feasible. So one of the things that I'm going to be working on during my deployment is coming up with essentially the range of accuracy by looking at how many running simulations and tests of where we know how many devices traverse the network versus how many we calculate. Based off the preliminary test, even with the channel hopping, it's extremely accurate. It's in the 90 percentiles of being able to capture most devices that are broadcasting. And a lot of this is simply because of the frequencies in which probe requests and all that stuff happens and stuff that we're able to cycle through pretty fast and capture that. And where the accuracy drops is the faster they're going. You know, if they're going 90 miles an hour, I may not be able to catch them on a single node, but I'll be able to catch them on the next node. And if they just appear on the second node, and I understand the topography and the checkpoint or the choke points, odds are I'm going to be able to calculate whether they're coming from the left or from the right, and I'm going to be able to extrapolate that based off any. If I can get 2 data points within the grid, I can pretty much calculate everything else. NTP. Yeah, and so yeah, you definitely once we get the GPS integration into, ideally I want to be actually build a actual predefined sensor module that contains all of these elements. I want XP. Guess what? All of that in 802.11 you can do in Bluetooth, and it's much more effective because you can some of the Bluetooth systems. I've got a Bluetooth dongle. I've got a Bluetooth, and there's a few others. This is simply from detection, which is all we're doing. We're not doing interaction. So ideally, if we get to a multi-level thing where we're doing wireless, XP, or 802.11, 802.15.4, Bluetooth, I don't remember what the spec for that one is or whatever, is stuff. Good luck. If you slip up, if you've got one device that's broadcasting, we're going to find it. And if you've got two, like, so you've got, how many people have the LG headphones? Yeah, like that. I've got a pair, okay? Well, guess what? If you've got that on, I've got 2 data points on Bluetooth automatically. I've got that, and I've got your phone. And if you've got your wireless now, I've got a 3rd one. And when you start being able to do, from a surveillance standpoint, this is all metadata, because we all know metadata is completely harmless. But I think I'm proving otherwise. Yeah, it's being able to do data correlation, of being able to tie 2 points together, especially when they're moving in a nice controlled form through the grid. Yeah, there's definitely a correlation there. So, but the good news is, if you lose your device in my network, I'll be able to find it. For a call. Whether, as long as it's broadcasting, and once I get Bluetooth and integration stuff, as long as it's got any outside of the actual cellular broadcast, if there's any consumer wireless communication going on at all, we'll be able to find it.
Yeah.
So
just look up fox hunting, amateur radio fox hunting.
Yeah.
It tells you all about how to do this.
Yeah, it's fun stuff.
A lot of times when they ever got Wi-Fi on the thing, we'll send them his port to get a good connection, which I give permission to.
Don't cancel the meeting yet.
Yeah.
I'm just going to stop the screen sharing, I think. So.
You could humor me and do an apt-get install BWM-NG and then run it while we still got the hang out running. Jace?
So thank you, Tim.
I don't, what am I doing?
Apt-get install BWM-NG.
Apt-get install
BWM-NG.
Mic check. Okay, so Southeast Linux Fest, June 12th through 14th, Sheridan, Charlotte Airport. Thanks everybody for being patient as we got the equipment up and running. I would have been here earlier and we would have been on time, but somebody probably did something stupid on the interstate, so it took me a long time to get here from Spartanburg. If anybody after the meeting wants to see the Raspberry Pis, I brought the Raspberry Pi stack thing that's going to be registration itself. Basically, every one of those I'm going to plug into a lap dock, and ta-da, I have registration terminals for like $100 a pop. I guess that's it. Any questions about Self this year?
When is RFP?
It will open this month. Stay tuned.
Okay.
If you're not on the announced list, join it.
Yeah, in conjunction with Southeast Linux Fest, there's also B-Side Charlotte this year as well.
Correct.
Which will be on Saturday. So it's a security conference, almost completely security focused, although there will be some overlap. I highly encourage you guys to check out those tracks, that track as well. The call for papers for that one is still ongoing. Don't know what the lineup is, but it's always a good event, and I definitely encourage you to support those guys as well, because the information security industry is probably one of the biggest contributors to open source, and different aspects of from our security and actually getting things patched and working. So I highly encourage you guys to check out what they're doing, and if you're there, pop your head in for some really, really awesome talks.
Yeah, I have a bit of an odd question. I'm actually working with the art guy for the conference on an art concept. It'll be the 7th Southeast Linux Fest. So 7, you think Vegas, obviously. So our art concept for like the T-shirts and the program guides is actually Tux dressed like Hunter S. Thompson at a craps table, throwing dice directly at you. And to the left, the FreeBSD daemon. To the right, the NetBSD pufferfish, and then the Android. So we have like room for one more Fosse kind of living thingish thing, but we can't think of another. Anybody got any ideas?
I've got one, but I'm not going to say it. Octopussy.
Oh, God. Ones that I won't catch crap for.
Potentially Octocat from GitHub.
Maybe, yeah. And B-sides might actually be part of that artwork. We might roll it all into one artwork.
If they sponsor.
Call them.
It's my job to be money grubbing, not yours. So any other questions about self?
So give us a little spiel of what's changed. What are we alphaing tonight?
I suck at video editing, and it takes me a long time, and every time I'm like, I'm going to do some videos, I'm like, I got to drop a transmission in my car. I'm going to do some videos this weekend. Oh, crap, I'm going to close on my house. I'm going to do some videos this weekend, and so on and so forth. So this year, instead of collecting a terabyte plus of data that I have to then maul through, we're going to try to do Hangout live streams of all the talks and just pump it immediately to YouTube. The downside of that is it's not going to be the same quality we get as using the on a Uber tripod professional cameras we were renting, but it's actually, I mean, it's not too bad. And actually not that expensive. Bandwidth cost a lot more because obviously we need a big upstream.
We've also found better suppliers. So we also were able to, the cost increase is minimum.
Sweet. So yeah, so hopefully after this year's self, when everybody invariably comes up to me and I'm semi-zombie mode and they go, so when are we going to get the videos? This year I'll be able to say,
they're up.
Already on YouTube, and drop the mic. Any other questions?
So the equipment, you've got Raspberry Pis for registration.
Raspberry Pis will be registration. We got 5 Pis and 5 docks, and they'll just sort of all be lined up. In terms of the AV stuff, it's just some VHF, UHF mics, a simple little all-in-one PA that's got some backup mics as well, so if our mic kit dies, we can still at least go to PA, even if not out on the stream. And some laptops, some ThinkPads, but of course, except no other substitute for your laptops. And so, because it's not really feasible to expect all of our speakers to show up with an updated Google Talk plugin and an updated everything else, that means we have to provide all the laptops. Because I guarantee you, if we ask 60 people to show up with exact, current, up-to-date versions of Google Talk, maybe half of them would.
Yeah.
So it's a little bit more expensive up front compared to just renting the equipment like we typically do, but starting, obviously, next year, the cost for video production go way down. Other questions? Hearing none, I will turn it back over to Jace.
Okay, well, thank y'all for coming. Any questions in a general sense? I have a question. Who's going to talk next month? All right, so I guess we could kill the feed.
Run BWM. I want to get a bandwidth measurement.
Bandwidth measurement? Okay, so we're going to get a bandwidth measurement. Anyone have any general Linux questions or anything like that? Something we want to discuss in the future, perhaps, or problems you're having at home, at work? Yes. An Asus EEE laptop, you said? Lubuntu, you said? I don't know. SD card. Boot off the SD card? Right. Well, I think for in order for I'm thinking in order for a device to boot off the SD card, you have to see if that device boots off an SD card in the same way like a USB thumb drive would boot. So you check the BIOS or the EFI or whatever. But like for example, the Raspberry Pis, they boot off of SD cards too. So it's possible to do if the hardware can do it. So yeah, you just need to create a I don't know a bootable SD card. So does that make sense? I mean, you put everything on that SD card and then have it boot into that. Yeah, you could definitely do that. You could boot off the hard drive. You could boot off another thumb drive, for that matter, or off an ejectable DVD for whatever, and then have that be your root file system. Just do a pivot root sort of thing and go into that, or have it mounted as a data drive or something like that. You could do that sort of stuff. All kinds of possibilities. What's your use case? Any other questions? Yeah. Hey, Inslee. UCache? Oh, GNU Cache. Oh, the accounting software? Yes. Yeah. The double entry stuff. Yeah. There's a couple years ago, one of our members had given a presentation on GNU Cache. I don't know if we recorded it or not. I'm thinking we probably didn't. But it's it takes a lot to set up, and I don't. Have you got experience with it, or? On the help of GNU Cache tutorial.